IPv4 Address Classes Review. IPv4 addresses are divided into 5 classes. A, B, C, D, and E. Classes A, B, and C are commonly used for network addressing. Class A addresses have a range from 1.0.0.0 to 126.0.0.0 and allow for a large number of networks. The first octet represents the network portion, while the remaining 3 octets are available for host addresses. For example, 10.0.0.0 is a Class A network address, and it can have up to 16,777,214 hosts. Class B addresses have a range from 128.0.0.0 to 191.0.0.0. The first 2 octets represent the network portion, and the last 2 octets are used for host addresses. For instance, 172.16.0.0 is a Class B network address, allowing for up to 65,534 hosts. Class C addresses range from 192.0.0.0 to 223.0.0.0. The first 3 octets denote the network portion, and the final octet is reserved for host addresses. An example of a Class C network address is 192.168.0.0, which can have a maximum of 254 hosts. Maximum hosts per network. The maximum number of hosts that can be accommodated within a network depends on the class of the IP address and the number of available host bits. In Class A networks, the first octet represents the network portion, leaving 24 bits for hosts. Since each bit can have 2 states, 0 or 1, there are 2 to the power of 24 possible combinations. However, the first and last addresses, network and broadcast addresses, are reserved, so the maximum number of usable hosts is 2 to the power of 24 minutes 2, or 16,777,214. Class B networks have the first 2 octets as the network portion, providing 16 bits for hosts. Following the same logic, the maximum number of usable hosts in a Class B network is 2 to the power of 16 minus 2, or 65,534. Class C networks allocate the first 3 octets to the network portion, leaving 8 bits for hosts. Thus, the maximum number of usable hosts in a Class C network is 2 to the power of 8 minus 2, or 254. First and last usable address. Within a network, the first and last addresses have special significance. The first address, known as the network address, is used to identify the network itself. It represents the base address of the network and cannot be assigned to any host within that network. For example, in the Class C network 192.168.0.0, the address 192.168.0.0 is the network address. The last address, called the broadcast address, is used to send data to all hosts within the network simultaneously. It is used for broadcasting network-wide messages. Continuing the previous example, in the Class C network 192.168.0.0, the address 192.168.0.255 is the broadcast address. All addresses between the network address and the broadcast address are assigned to individual hosts within the network. For instance, in the Class C network 192.168.0.0, the host addresses would range from 192.168.0.1 to 192.168.0.254. Show IP Interface Brief Command. The Show IP Interface Brief command provides a concise overview of IP interfaces on a Cisco device. Let's say we execute this command on a router and obtain the following output. Here we can see 3 interfaces listed: Gigabit Ethernet 00, Gigabit Ethernet 01, and Loopback 0. Key IP addresses, status, and protocol columns indicate the IP address assigned to each interface, their operational status, up or down, and the protocol status, up or down, respectively. IPv4 Address Configuration. Configuring an IPv4 address involves assigning an IP address and subnet mask to an interface. Let's say we have a Cisco router with the following interface configuration. In this example, we assign the IP address 192.168.1.1 to the Gigabit Ethernet 00 interface. The subnet mask 255.255.255.0 represents a Class C network, as it uses 24 bits for the network portion and 8 bits for the host portion. Show Interfaces command. The Show Interfaces command provides detailed information about individual interfaces on a Cisco device. Let's consider the following example, output for interface Gigabit Ethernet 00. Here, we can see various details about the interface, such as its status, up or down, line protocol status, hardware type, Gigabit Ethernet in this case, MAC address 0011-2233-4455, assigned IP address 192.168.1.1, with its corresponding subnet mask, represented as 24, maximum transmission unit, MTU, bandwidth, BW, delay, DLY, reliability, transmission load, TX load, and receive load, ARX load. Show Interfaces Description command. The Show Interfaces Description command allows us to view the descriptions assigned to interfaces. Let's say we execute this command on a Cisco device and obtain the following output. In this example, we have 3 interfaces with their corresponding descriptions. The interface description provides a brief explanation of the interface's purpose or connection, making it easier to understand and manage the network. Configuring interface descriptions. Adding descriptions to interfaces helps with network documentation and organization. Let's say we want to configure a description for Gigabit Ethernet 00. By applying the above configuration, we assign the description Main Network Connection to the Gigabit Ethernet 00 interface. This description serves as a useful reference when identifying the purpose or role of the interface in the network. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.